In this lecture, we will cover the basics of fractions, reducing fractions, and equivalent fractions. We will also use the concept of prime factorization. We will begin with the basics of fractions. A fraction is a number a over b, where a is the numerator and b is the denominator. A fraction may be represented as a over b, but it may also be represented as a slash b, which is another way of writing the fraction, or we can write it as division, a divided by b, using the division symbol. For our first example, we will consider an area model since it gives a visual as to what a fraction represents. The diagram below represents a rectangle divided into 7 equal regions. Shade in the parts of the diagram that will represent the fraction 3 over 7. Since there are 7 rectangles that make up the whole rectangular shaped region, we represent the fraction 3 over 7 by shading in 3 of the small rectangles. The shaded regions represent the fractional part of the whole. For our next example, we just need to identify the numerator and the denominator of the fraction 7/9. Simply put, the numerator is the top number of the fraction, therefore the numerator is 7, and the denominator is the bottom number of the fraction, which is 9. For our last example in this part, what fraction of the 11 shapes are circles? The 11 shapes represent the whole set of shapes. The 5 circles represent a fractional part of the whole. To write the fraction, we let the denominator equal to 11 and we let the numerator equal to 5. Therefore, the fraction of 11 shapes that are circles is 5/11. We will now briefly look at the difference between proper and improper fractions. A fraction for which the numerator is smaller than the denominator is called a proper fraction. A fraction for which the numerator is larger than the denominator is called an improper fraction. Some believe that when the numerator and the denominator are equal, this is also considered an improper fraction. For our example, we will find the proper and improper fractions from a list of fractions. The proper fractions are 5/7, 4/9, 3/4, and 7/15. Notice what they all have in common. The numerators are smaller than the denominators. The improper fractions are 7/5, 10/2, and 11 over 10. Notice that all the numerators are larger than the denominators. Also notice that 10 over 2 is actually the whole number 5. We will now look at reducing fractions. We will consider a property for canceling common factors. This property will allow us to reduce fractions. We will use the variables a, b, and c to represent numbers in our property. Let a, b, and c be natural numbers greater than 1. Then a over b times c over c equals a over b. This is true since we can cancel the c over c. This rule illustrates that we can cancel a factor that is common to both the numerator and the denominator. This process is known as reducing the fraction. When all common factors have been canceled, the fraction is considered to be in lowest terms. Some books may use the word simplify or simplified terms. We will now consider some examples of writing fractions in lowest terms. For the first one, Write the fraction 32 over 40 in lowest terms. Notice that the last digits of both the numerator and denominator are even numbers. Therefore, both 32 and 40 are even and are divisible by 2. That means we can divide 2 evenly into both of these numbers. When we divide 2 into 32, we get 16. So we can write 32 as 16 times 2. And when we divide 2 into 40, we get 20. So we can write 40 as 20 times 2. Canceling the 2's gives us 16 over 20. However, 16 over 20 is not in lowest terms. 16 and 20 are both even numbers. Therefore, they are divisible by 2. When we divide 2 into 16, we get 8, and when we divide 2 into 20, we get 10. Again, we can cancel the 2's, leaving us with 8 over 10. 8 over 10 is still not in lowest terms because both of these numbers are even. As long as both the numerator and the denominator are even, the fraction is not in lowest terms. Therefore, we can divide 2 into both 8 and 10, giving us 4 times 2 over 5 times 2. Canceling the 2's gives us the reduced fraction 4 over 5. Another approach to this problem, if we recognize that 8 is a factor of both 32 and 40, will allow us to reduce this fraction into lowest terms in one step. That is, 8 will go into 32 4 times, and 8 will go into 40 5 times. Canceling the 8's leaves us with 4 over 5. Therefore, 32 over 40 in lowest terms is 4/5. We will now consider equivalent fractions. To determine if two fractions are equivalent, set the two fractions equal and cross multiply. If we get the same number on both sides of the equal sign, then the fractions are equivalent. We will look at an example. Determine whether the fractions 35 over 56 and 55 over 88 are equivalent. We first set the two fractions equal. We then cross multiply. We first multiply 35 times 88. Then we set that equal to 56 times 55. We will get 3080 on both sides of the equation. Since the two sides are equal, the fractions are equivalent. We will now find an equivalent fraction given a fraction. We will begin with the property for multiplying fractions by 1 to find an equivalent fraction. In the property, we will let variables represent numbers. Let a, b, and c be non-zero integers, then a over b times c over c equals a times c over b times c. Recall that any number over itself is 1, so multiplying a over b times c over c is the same as multiplying it by 1. We can do this as long as c does not equal 0. We will now consider an example. Find a fraction equivalent to 4/5 by multiplying by 3 over 3. We start with our reduced fraction 4/5. We multiply by 3 over 3. Multiplying the numerators and multiplying the denominators gives us 12 over 15. Notice that we have found a fraction that may be reduced. So we can view multiplying a fraction by 1 to find an equivalent fraction as the opposite of reducing the fraction. In our next example, we will rewrite the fraction with the indicated denominator. We will use multiplying by 1. Notice that the denominator 63 was obtained by multiplying 7 times 9. You can find this simply by dividing 7 into 63. Therefore, we will multiply the fraction 3 over 7 by 9 over 9, which is the same thing as 1, to obtain equivalent fractions. Multiplying 3 over 7 times 1 is the same as multiplying 3 over 7 times 9 over 9, giving us 3 times 9 over 7 times 9, which equals 27 over 63. Therefore, the numerator that we were seeking is 27.